So hi, I'm going to be talking to you today about natural language processing. So this year I had the pleasure of attending WWDC, and I was able to attend a session on natural language processing. Going into it, I knew very little about the topic, except that it had something to do with machine learning and linguistics. And I actually, as Kate mentioned, I do have a little bit of a background in linguistics because I studied English in school. And it's also of particular interest to me being a non-native English speaker and having the experience of learning a second language. And I've always been fascinated by language in general, so I was really excited to attend the session and to learn how to apply linguistics in our applications. So let's get started. All right, so what exactly is natural language processing? Essentially, it's a field in computer science, artificial intelligence, and computational linguistics, and it concerns itself with the interactions between computer and human, otherwise known as natural languages, and in particular with programming computers to process a large amount of natural language. So again, I got to attend WWDC this year, and one of the most exciting announcements was CoreML, this new CoreML framework, which if you haven't had a chance to play with it yet, I highly recommend it. It's really cool to see this stuff in action. But what's really cool about CoreML is that it allows us to incorporate machine learning into our apps without having much prior knowledge of how it works or experience with it, and you can get up and running really quickly. The CoreML framework also supports several domain-specific frameworks, including vision, so that allows us to add high-performance image analysis and computer vision to our apps. Gameplay Kit, which it allows us to architect and organize the game logic for gaming apps. And last but not least is Foundation with natural language processing. If you haven't had a chance to check out the session, I definitely recommend it. It's really cool. All right, so the NLP APIs are already being used and have been for a while in some of the apps that we already know and love, most notably Siri, which actually when the APIs were first released, there were rumors that Siri was, so the APIs were a byproduct of the development of Siri. So who should use the APIs? Basically, anyone whose app handles natural language at the input or output can use the APIs. And by that I mean maybe your app consumes a feed from an API, or maybe your users are generating content within your app in the form of typed text, recognized handwriting, or transcribed speech. So what we want to do now that we have the raw text is convert it into useful information that we can then use to improve the experience between our user and the device, or between two devices. And what's happening in the middle there is not actual, Cinderella magic, but natural language processing. But let's go back a step and try to understand what we mean by useful information. So to do that, we're going to have to look at the fundamental building blocks of natural language processing. Starting with tokenization, which basically means segmenting text into a specified unit that could be paragraph, sentence, or word. It doesn't seem particularly interesting or impressive at first glance, but it allows us to accomplish the other tasks, including language recognition, part of speech, so determining whether a particular word may be a noun or a verb, etc. Limitization, which is a fancy NLP word that essentially means getting the root form of a word. So the lemma. And in English, that would mean the word without any pluralization or verb tenses, perhaps, or maybe the possessive form. And in Spanish, it's a little bit more complicated because there are a ton of irregular verbs. But yeah, so the last one is name entity recognition, which is identifying whether a word or a set of words corresponds to a person, name of an organization or company, or maybe a location. So now we know a little bit about NLP and how it works. Let's look at the class that helps us accomplish all these tasks, and that's the NS Linguistic Tagger class. It's a class in Foundation, which means it's available across all platforms, and it has been available actually since iOS 5. what it does for us is it segments and tags our text according to a specific tag scheme, otherwise known as a linguistic task. Definitely check out the documentation on this. It's really helpful. Some of it is still in beta, but it's not too different from what it was. So because it's been around since iOS 5, let's see what's new in this linguistic tagger. We have the concept of units, which didn't exist before, so we can specify whether we want to tag a specific body of text for at which level, so a sentence perhaps, or individual words. We can also check for which schemes are available using the available schemes function, and we can pass in language and units for that. We can also grab the dominant language for a specific body of text in text that may contain multiple languages, perhaps. There are also now name types for tags and tag schemes as a Swift 4. They used to be strings, and they were a little bit clunky to work with, so they've gone ahead and made them a little bit more Swifty. But I would say the most impressive thing is how much work Apple has put into sort of refining the tagger class and making it more accurate than ever. And they've provided additional language support. So I have a chart here, which may be a little small, but so the higher, like the more fine-grained tasks, such as Limitization, part of speech, and name entity recognition, are actually limited to, I think, 8 languages, but I'm hoping that they'll expand that in the future. All right, so now let's take a look at the code. I love this GIF. All right, so language identification I played around with in Playground because this is just like really quick and easy to get it up and running. So the first step is we initialize our NS linguistic tagger with whatever tag schemes we're interested in. Options we'll get into later, but in this case, we're only interested in the language tag scheme. So we set the string on the tagger. This is a sentence in Spanish. No one who speaks Spanish judge me if I'm missing a tilde or something. It's been a while. So, and then we just call a dominant language, and we get the response which corresponds to Español. Pretty quick. So tagging tokens is a little bit more complex. Hopefully you can see this, but it's essentially we're doing the same thing. We are initializing our linguistic tagger. This time, because we don't know which unit I might be passing into this function, I'm using the available tag schemes and specifying the language because for my sample app, I just worked with English. So then I set the tagger string again. The range, in this case, is the full length of the text. The options, specifically, I just want to ignore any white space and anything that might be identified as unknown. So I call omit space and omit other. And then so we have the meat and potatoes of this class. Basically, we enumerate through each token, so in this case, each word. And we pass in our range, unit, scheme, and options, and then this closure is called, which takes the arguments for tag, token range, and there's a third, not particularly relevant, it's a stop, which would just essentially stop enumerating, but I'm just like leaving it out there, and so what I'm doing is, for my needs for this particular app, I'm just like collecting all the tag tokens in an array, which I use later. So name entity identification is not very different. In this case, we know which tag scheme we want to use, so we can specify that when we initialize the tagger. Again, we pass in the string and the range. What's a little bit different here is under options, we're including join names. So if we're going through perhaps a text that contains personal names, we will join first and last, or maybe like a city that's like New York, where it's multiple words, we'll make sure to join those as one. And also, in this case, we're looking for 3 specific tags that I use this array that contains personal name, place name, and organization name, so that when we receive our tags, I can check against that array to make sure it's the ones that are relevant to my needs. Again, returning an array with my tag tokens. So I came up with a sample app to show several examples of this in action. And the first one, this is a fantastic article from BuzzFeed about what happened in that elevator with Jay-Z and Solange. If you haven't read this article, I recommend it. So I'm scanning the text and I'm analyzing it for parts of speech. This is like specifically verbs, and as you can see, even in contractions, we're able to extract the verbs here. Here I'm using name entity identification, and as you can see, the names are highlighted here. It didn't recognize title. I'm not sure why, but yeah, I have theories. So, and then the last here, I'm specifically identifying nouns, and I guess one cool thing here is that it was able to identify a sort of a more casual version of you and ya. And maybe it's not that interesting to you, but I'm a word nerd and that fascinated me. Okay, so next we'll look at limitization. And this is really useful in searches. So what I did here in this example is I have a text from just a random article that I pulled from the internet on Rotten Tomatoes and why you should never trust it. And then, so what I do is I enter a search term, and then that search term is limitized, so it will then be matched with all of the text in my text view, in whatever form that word may be in. Yeah, there we go. So here's an example. Type in movie, and you get the plural form and the possessive form, and then there's another search term, which essentially does the same thing. So yeah, it works pretty well, and I would say it's the most useful when doing a search, so you don't have to try to find an exact string match. It might be super useful, especially when you're using another language, I would think, especially with Spanish, which has like a ton of irregular verbs. All right. Oops, skipped one. So my sample project is up on GitHub. There are a few other examples in there, and also there's a playground if you want to just like see how it works really quickly. Oh, someone's taking a picture. Go for it. Okay, so what are the benefits of using the NLP APIs? First, because we are using the same APIs that are used across Apple apps, you'll have a consistent experience. Second, it's all happening on device, so you're protecting your user's privacy. And last is performance. It's clear that Apple has put a lot of work into this, and it's been optimized for on-device, so that means you're minimizing memory footprint and power consumption. Also, it's responsive in the sense that it'll work with or without a network. It's now multi-threaded, so if anyone has been using the APIs in their app already, you'll see a significant increase in speed. But I think the most interesting and compelling case for using them is that the models are being continuously updated. And this actually happens over the air. And the way to make sure you're getting all the updates is to download the keyboard for the language that you're interested in working with. So what didn't work so well, because if anyone, if you know me from Twitter, I'm pretty honest and I tend to overshare, so I'm going to tell you everything that didn't work well. So name entity identification was limited. And this was specific because, I'm in tech, so I decided to scan or analyze an article that mentioned a lot of tech companies, including Twitter and Facebook and BuzzFeed. And for some reason, those companies were not recognized as organizations, but others like Squarespace and maybe Shutterstock, and I think Tumblr were identified. So I have my theories about why, but I won't get into it. You can talk to me after. So language identification within the same sentence didn't work too great either. I tried to pass along some Spanglish because I thought that would be really fun to play around with. And if I changed like one word in a sentence, then it would affect how the other words were analyzed. And I think it's maybe because they're too close to the language. They're pretty similar in alphabetically. Maybe. I haven't tried with other languages. If you do try it, let me know, because I'd be curious to see how it works. And the single word tagging, so when I had to tag my search term in my limitization example, I couldn't get this to work. I kept getting a nil response. So what I had to do is get like really hacky and just like add some text before my search term and then just ignore the rest of it and only get the tag for that final term that I was interested in. I think the phrase was something like, please show me, and then my search term. I got it to work, but it's not ideal. I do think it's not a bug, though. I think it's more that it's hard for the tagger to identify what we mean by a specific word without having any context. So some cool projects to check out if you're interested in looking at other projects, and I recommend it. The WWDC session contained 2 really good examples of how to incorporate these into hypothetical apps. So Ayaka had a really great talk at Realm a couple years ago on natural language processing, in which she discusses, she uses the APIs to train a model to identify spam. It's like a spam detector, but it's fun, it's a little complex, but I definitely recommend checking out that talk. The only thing is that it is, oh, lost something. It's not up to date. It's because it's a couple years old, so it's not using the Swift 4 APIs, but it's pretty similar. You can follow along. And the last is Martin has a great blog post that was written recently where he's using a simple algorithm along with the APIs to find key terms in some of his blog posts. And that's me. I hope that you found this topic interesting and you're getting some ideas about how to incorporate NLP in your apps. And I'd love to hear your ideas at office hours, so definitely come talk to me. Thank you.